Hello students, today we will be discussing another new concept called as hypergeometric distribution. So students, under discrete probability distribution, we already saw Bernoulli, binomial and Poisson distribution. The final one under discrete probability distribution is hypergeometric distribution. Before getting to know the formulas of hypergeometric distribution, let us at least know what hypergeometric distribution is. Understand? Hypergeometric distribution plays a very significant role in statistical distributions. Let me tell you certain interesting features about this hypergeometric distribution. Firstly, remember, hypergeometric distribution will be possible or to be calculated only when it is a finite series. That means we need to know the number of terms which are there when we do hypergeometric distribution. The second feature of hypergeometric distribution is, students, we need to know that hypergeometric distribution will always have only two categories. Hypergeometric distribution will have only two categories. Now, how can I give you an example for this? For example, in a class, there are students, there are only two categories of students. Either there are male or there are female students. In a basket, either there are good mangoes or there are bad mangoes. Two categories. So students, that is how hypergeometric distribution condition can be used only when you have two categories. Very interesting feature, students, is the next one, which you have studied in the first PU in probability as well as random sampling. Hypergeometric distribution follows sampling without replacement. Sampling without replacement. That means, imagine there are 25 mangoes in a box. 25 mangoes in a box, in which 10 are good mangoes, 15 are bad mangoes. And first time I am picking 5 mangoes from the good ones. So I will pick up 5 mangoes from the good ones. Once I pick up 5 mangoes, I will not put it back into the box again. I will take it and I will keep it separately. So what happens is, I have removed 5 mangoes from this. So only 20 mangoes will remain. That means the next probability when I use, again when I pick up 10 mangoes, the total mangoes will not be 25, it will be only 20 because 5 are already removed out. And that is called sampling without replacement. That is nothing but when we remove certain items, we do not replace it back again, and that is the speciality of hypergeometric distribution. And the next property or the next feature of hypergeometric distribution is, it has successive selections. The selections are not done together, as I told you here. Same example again. First we select a few good mangoes. Once that is done, once those are kept aside, then we go to the selection of bad mangoes. That is, selection happens successively, and that is why, students, when selection happens successively, remember, even the probability of success keeps on changing after every draw. That means when I pick up the first few things, the probability is different. For the second draw, the probability will be different, and that brings us to the probability mass function of hypergeometric distribution. So students, carefully follow the probability mass function for hypergeometric distribution, it is P of x is equal to ACX into BC n minus x divided by A plus B combination n, and definitely we have a range for it. X is equal to 0, 1, 2 up to minimum of A and n. Minimum of A and n. So understand the students, this is the probability mass function. P of x is equal to ACX into BC n minus x divided by A plus B C n. And the range is x is equal to 0, 1, 2, minimum of A and n. What is this A, B, x, n? What are all these? Understand, this is nothing but very important, students. N is the total samples that we are picking up. A plus B is the total data, that is good mangoes and bad mangoes. 10 plus 15, that will be A plus B, which is 25. C is nothing but the sample drawn. Say I have to draw totally 12 mangoes. Totally 12 mangoes. In the first one I will draw 5, and from this second I will draw 12 minus 5, which is 7, and that is what is required here. A means good mangoes in this example, B means bad mangoes in this example, C in the sense first I am drawing 5 mangoes, n minus x means totally 12 mangoes I had to draw, 12 minus 5 is the remaining one, that is 12 minus 5, 7, A plus B I already told you the total, and that is the probability mass function, which is P of x is equal to ACX into B C n minus x divided by A plus B C n, and the range is x is equal to 0, 1, 2 up to minimum of A and n. That means whichever is a smaller number, we will write it that one as the range. For example, in this one, if you see, A is nothing but the good mangoes at 10, n is nothing but 12. So 10 and 12, which is smaller? 10 is smaller. So we will write the range x is equal to 0, 1, 2, 3 up to 10. Whichever is the smaller number between A and n, that number will be considered as the range. One more important feature, students, of hypergeometric distribution: always, be it A value, be it B value, or be it n value, all the three values need to be greater than 0. All these values A, B and n should be greater than 0. Finally, like every distribution, Bernoulli, binomial, Poisson, even hypergeometric distribution should have mean, should have variance, and should have standard deviation. Firstly, let me give you the formula for mean. Formula for mean is n into A divided by A plus B. N into A divided by A plus B. This will be giving us the mean. Variance is equal to, little lengthier formula, but I think as second PU students you should know this formula very well. It is n into A into B, open the bracket, add the commodities given A plus B, minus it with the sample that is there, n. Don't forget it to divide it by A plus B the whole square. Again, like the numerator, A plus B minus, not n this time, it is 1. N into A into B, bracket A plus B plus N divided by A plus B the whole square into A plus B minus 1. What will be the standard deviation, students? Standard deviation will be the same thing as the variance but square root. So, I will not write the entire formula again. I will only write standard deviation is equal to square root of variance. Like every concept, Bernoulli, binomial, Poisson, even for hypergeometric distribution, standard deviation is the square root of variance. So, quickly in a nutshell, students, hypergeometric distribution is for a finite series. There will be always two categories. Sampling is done always without replacement. That means things which are taken once are not considered once again. There are successive selections of draws. That means the probability will be changing with every draw. And I gave you an example here. And with that example, the probability mass function is P of x is equal to ACX into BCN minus x divided by A plus B, Cn, everything in combinations, whereas the range x is equal to 0, 1, 2, and we consider the minimum value between A and N. Remember, the value of A, B and N should always be greater than 0. Mean is equal to N into A divided by A plus B. Variance is N into A into B, open the bracket, A plus B minus N divided by A plus B the whole square into A plus B minus 1, and finally standard deviation is nothing but the square root of variance. Keeping all these things in mind, let us move forward with the questions on hypergeometric distribution. So, students, we saw the hypergeometric distribution, we saw its various features, we discussed about its probability mass function, we also discussed about the mean, variance as well as standard deviation, and now it is time to deal with one problem of hypergeometric distribution and also to cover all the aspects that we studied theoretically. Let us see the question first. A pond has 30 fishes, among which 10 are marked ones. So, understand this, there are 30 fishes in total, okay, total there are 30 fishes, 10 are marked ones. That means remaining is how much? 30 minus 10, which is 20, those are unmarked ones. 4 fishes are caught from the pond. How many fishes are caught? 4 fishes are caught. Okay. Find the probability that 2 of them are marked ones. We have to find the probability that 2 of them are marked ones. That's the first part. And second part of the question says also find the mean and variance. Let us deal with that part later. So, students, understand firstly, when we look at the question, we need to know that this is hypergeometric distribution because there is 2 different categories here. Total 30 fishes, 10 are marked and there are remaining also. That means this is 2 categories, marked and unmarked. That means it is a hypergeometric distribution. Let us take down the data now. So, we know that it is a hypergeometric distribution. So, I will write here firstly A plus B, which is total number of fishes, which are 30. A, the marked ones are given to me as 10. That means B, the unmarked ones become 20. 4 fishes are caught from the pond. 4 fishes, that means N is equal to 4, and whatever we have to find out, that becomes X. Probability that 2 of them are marked ones. They have not given at least 2, they have not given at most 2, they have only given 2 of them are marked ones. That means X is equal to 2, this is given to us. So, firstly, let us write the probability mass function for hypergeometric distribution. What is it? It is P of x is equal to, if you remember from the previous case, we have written the PMF of a hypergeometric distribution. So let us recall it once again. It is P of x is equal to ACX into BCN minus x divided by A plus BCN, and this follows the range x is equal to 0, 1, 2, minimum between A and N. So, we have to find, students, the probability of, what is the question given? Two of them are marked ones. Probability that two fishes are marked ones is equal to P of x is equal to 2. P of x equals to 2. And how do we write the probability mass function now? What is A? Just substitute looking at here. A is 10, C, x is 2 into B is 20, C, N is 4 minus x is 2 divided by A plus B totally is given to us as 30. C, what is the value of N here? N is nothing but 4, comma, x is equal to 0, 1, 2. Up to where will we write this, students, the range? I told you it has to be minimum of either A or N. So see here now. A is 10, N is 4, which is minimum. 4 is minimum, so we will write x is equal to 0, 1, 2, 3 and 4. Simplify this, students, it should be 10 into 9 by 2 into 1 into 4 minus 2 is 2. So it is 20 into 19 by 2 into 1. Divided by 30 into 29 into 28 into 27 divided by 4, 3, 2 and 1. Take your calculators, quickly simplify this. While you simplify, you need to get it 45 into 190 divided by 27,405, which, well, further simplified, students, you have to get 0.312. This ends the first part. Remember, students, be it Bernoulli, be it binomial, be it Poisson or hypergeometric distribution, always remember that your probability answer should lie between 0 and 1, because the probability always is minimum 0 and the maximum probability it can attain is always 1. Even here the answer is between 0 and 1, that is 0.312. Coming back to the question, we didn't finish it yet. We have the second part which says find the mean as well as the variance. Let us not waste any further time. Let us quickly do it. Mean. What's the formula for mean? Recall the formula, students, for hypergeometric distribution. Mean formula is n into A divided by A plus B. Let us directly substitute the values. N is 4, A is 10 divided by A plus B is 30, which is 4 into 10, 40 divided by 30, and the answer for mean is 1.33. And the last part of the sum is to find the variance. Let us know what the variance is. Variance is equal to, first recall the formula and write it down, n into A into B, open the bracket, A plus B minus n divided by A plus B the whole square into A plus B minus 1. So students, once you know the formulas, statistics is very, very easy. Okay, let us substitute now. N is 4, into A is 10 into 20, open the bracket, A plus B is given to us 30 minus N is 4 divided by A plus B is 30 square into A plus B is again 30 minus 1. Simplify this quickly in your calculator, students. Once you simplify, you should get the final answer as 0.7969. If you get this, the answer is correct. And by this, students, we have finished hypergeometric distribution as well. And this brings us to the end of discrete probability distribution under theoretical distributions. We finished Bernoulli, binomial, Poisson as well as hypergeometric distribution. So next we begin with continuous probability distribution from normal distribution.